All right, welcome everybody to this month's GlugNet meeting. Tonight we are pleased to welcome Cameron Presley, who's back again with us, to speak about code reviews, specifically code reviews that developers actually want. A little bit about us, if you're not familiar with the group, we are the Greater Lansing user group for .NET developers, also known as GlugNet. We are based out of Okemos, Michigan, pictured here on the map. Our meetings are held every month on the third Thursday and are free for the public to attend. We've got the link here for our meetup page. That's the best way to find out about what we've got coming up. We'd also like to thank our sponsors this evening. NIS Technologies, represented here by Sam Nasser, who is providing us the GoToMeeting space as well as recording of this session. The .NET Foundation, who helps pay some of our bills, and TechSmith, who is our normal in-person hosting site. As I mentioned, this is being recorded and posted to YouTube by Sam Nasser. A link to his channel and a QR code are there. So you can find this recording as well as past recordings if you want to hear some other presentations that we've received. If you have questions at any point during the presentation, please feel free to either drop them in the chat or to unmute and ask your question. But otherwise, we ask that you please stay muted just so we can all enjoy the presentation without background noise. At the conclusion of tonight's presentation, there will be a survey link that is anonymous, and it's going to provide our speaker tonight with feedback on his presentation. So we would really appreciate if you would fill that out. Additionally, we are looking for feedback on prizes for future GlugNet meetings. So there is a link in the QR code as well. If you would be willing to give us some feedback on what kind of prizes you would like to see us raffle off, that would be greatly appreciated. Without further ado, it is time for our feature presentation.
Yep, as Steve mentioned, my name is Cameron Presley, and I'm here to talk to you all about how to have code reviews developers actually want. But actually, the alternate title to this session might as well be how to actually talk to other people like a real human being. And that's what we'll be covering this evening. If you are wanting to know more about the slides, books, and articles I reference, all of that information is live right now. You can either scan the QR code, go to the URL in the slide or in the chat and pull down everything. You'll get all the resources, but maybe not all of the meaning behind the resources, so your attention may vary. So with that being said, we'll go ahead and get into it. And the first thing I'm going to do is a very standard in technical presentations is ask a question to the audience, right? When I say code review, what does that actually mean to you? So you can throw it in the chat or say it out loud. I'm okay with either or.
First thing I think of is peer review of code.
Peer review code, okay. So any other takers as well about like what does code review mean or what feelings it might bring up to you when someone says a code review?
For me, it means having someone take a look at the code that I've done and see if there's a better way of doing it, and more importantly, if it's understandable without much explanation.
Yeah, no, absolutely. So
it can also be a time to make sure that you hit the target. What you accomplished, what the group understands needed to be accomplished.
Yeah, absolutely. I'm loving all of that because it's talking about the good parts of code review, which tells me you've all had some really positive experiences, which is great to hear. Let's talk a little bit about, though, some things I've seen. And one thing a lot of you all had mentioned was someone actually taking a look at it, reading it. But the downside of that is usually you get these PRs that kind of follow the looks good to me syndrome, right? So you have put your blood, sweat, and tears and a lot of effort to get this huge feature, this huge story done. You submit that PR, you share the link with your team, and someone just drops LGTM as it, maybe a thumbs up emoji if you're really fancy, and they just approve it. And it's kind of annoying, right? Because you put a lot of work in here, but it really feels like it was just rubber stamped, right? Did they actually read all of that code? Did they really look at all those changes? And when you feel like your code's being rubber stamped, it's kind of like a waste of time, right? So maybe not so positive of an experience. The other style of code reviews I see at certain places, especially if they're new to it, is one where there's lots of back and forth on something simple, right? So you're working on the code and you've realized like, oh yeah, we've got this weird inheritance thing. I'm going to switch out these 3 lines of code. Not a big deal. This should take all of 10 minutes. Famous last words. Because you submit that PR and then you start getting things like, well, what about this? Or did you think about these things? Or what are your thoughts on this totally different approach? And next thing you know, this simple 3 10-line change PR has now turned into a fist fight where everyone's got an opinion, everyone's coming out of the woodwork, everyone is saying, no, you should have done this, no, we should do that. And at the end of all of that, you kind of want to feel like this. Just retreat, go back, let them all figure it out, and then come back once all the fighting has kind of scrummed its way through. And it's unfortunate because this is also a waste of time. Somebody had mentioned making sure that we were on target, right? Usually it's because of a simple change, not maybe a line, that's caused these problems. So, but when we take a look at what a code review truly is, like any good tech presentation, I'm going to have a Wikipedia source here, right? A code review is really a systematic examination of computer source code, right? It's intended to find mistakes overlooked in the initial development phase, improving the overall quality of software. So a question I've got for the group is, have any of y'all ever had an experience where somebody was maybe apprehensive or really didn't want to do code reviews? And if so, can you talk a little bit about that experience? Okay. Well, hey, that may mean no one's ever had that experience, in which case, awesome. That means you got great places to work. But
I got one for you.
Oh yeah, what you got?
So I worked. It was at a bank, and basically the guy that was in charge of doing the code reviews, he just every time a code review was sent his way, his kind of roll his eyes in the back of his head, and he's like, I really much rather be working on my own stuff instead of reviewing other people's stuff. And it literally got to be a rubber stamp kind of a thing. I would send a request for a code review, and literally within 2 minutes, I got a reply back, everything's okay. So obviously he didn't even bother reading it. He's just rubber stamping it and moving on.
Yeah, and that's really annoying when that happens, right? Because because if they're just going to rubber stamp it, what was the point? And what I found when chatting with people doing code review is that they don't see the point, right? Like no one else does is I don't need someone else looking over my shoulder, right? And so here's what you can say when you run into individuals like that. Other professions have code reviews too. They just called slightly different. So when we talk to architects, right, like people who actually design buildings and such, they have they have peer reviews, but they're known as red line reviews. And the reason why they're called red line reviews is because architects would literally take a red pen and strike through the blueprint or whatever it is they're working on. Other engineers have peer reviews too. That's what it's called. Doctors have them. You just know them as consultations. And if you think this is only for white collar work, I've got an uncle who does a lot of welding. His welds get reviewed. They'll actually get x-rayed because if the weld didn't take or didn't work correctly, that can actually cause a real issue. Pressures building up and things exploding, which is not what you want. And if you think we only do this type of review at professional workflows, or like in a professional industry, we did this in high school, right? How many of y'all took like a high school or middle school English class and you wrote a paper and you had one of your peers read through it? Yeah, peer editing. And even that, we even have this in newspapers and other things called copy editing, right? So we've got this system for other professions and even school-age children to have their work peer reviewed by others. So why is it that we're kind of bad at it and also a little bit apprehensive about it? And in addition, let's go back to like one of the problems we're trying to solve, right? If we look back at the definition, it was intended to find mistakes overlooked in the initial development phase. So the question I've got for this group is, so why should we focus on finding bugs sooner? Anyone want to take a guess?
Well, the sooner you find the bug, the sooner you can fix it.
Well, sooner you can fix it. You're speaking like an engineer, which is good, but sometimes not great in business. Bugs cost more the later they're found, right? Yeah, exactly. The sooner you find the bug, the less it costs to fix. Here's the thing, though. How much cheaper or how much more expensive? That's really the question, right? Because the minute you start talking with people from the business side, they want to know the numbers because that's something a little bit more concrete to deal with. So in Steve McConnell's book, Code Complete Second Edition, he actually has a table based on some research he had been doing that talks about the how expensive something is. If you're not familiar with Code Complete, I think it's a fantastic book, even though slightly dated at this point, because it's one of the few engineering books I have found that combine both first-hand experience from the author, but also with actual industry research. So it's kind of cool that we have something that combines both, because in our line of work, we don't really get to research a whole heck of a lot. So when we look at that chart, we essentially have this. And so instead of giving you a dollar amount, it's really a kind of a scale factor of things. So you can kind of think of these as maybe scales of an hour. So if we were to look at this chart, right, let's say that while during the requirements gathering phase, as we're writing down the requirements, we could have swore that the product owner said tomato, but really they said potato, kind of close, but not quite the same. But once we followed up and like, hey, you're talking about like making a pizza, you said potato. Are you sure you said potato? And we're like, oh, no, tomato. And we fix it, that's a cost of 1. But the later we find it, the more expensive it gets. And so if we were doing requirements gathering, and now let's say we found it and fixed it while we were building the software, it cost 5 or 10 times more. And I'm like, okay. But the thing that always surprised me is that column all the way over at the right. So let's assume for a minute that you're working in a code base and you have the world's best requirements gathering process, never makes a mistake. You also have the world's best architecture. It is great, it is flexible, it's never the wrong thing. So we're only focusing on the actual writing of the code. Well, if you don't find that issue until after it's been shipped, Steve argues here that the cost to fix it is 10 to 25 times more. And when I first saw that, I was like, man, that makes no sense at all, because if it's like a 2-line fix, that takes me no time at all. But there's a flaw with that reasoning. That's the amount of time it took me. But I'm an engineer. That's very little time, right? Think about what's really happened. This code's working in production. Your customer or client's been working with it, and they find an issue, and it is a showstopper, right? They can't do what they need to do. So what do? They call in the support, right? They reach out. And now you've got a support team member taking a look at things and doing their basic troubleshooting. And then they've got to work out to engineers to see like, okay, is it user error? Is it an actual application error? And then what happens, right? They figure out it's a developer error. So then what? A new story gets created. It has to get refined. It has to get developed. It has to get tested, right? And you especially want to test this a little bit more thoroughly because it's a bug that your customer found, right? And then it's got to get released, and then it's got to get tested again to make sure that it actually worked in prod, right? All that takes time. So if you use this as kind of a like some back of the envelope math here, if you were to ever go into a new code base and you see that there's a lot of rework or bugs being generated, you can actually start figuring out how much that's costing the project, which can be a really fun exercise and maybe a way to talk to your business stakeholders about why certain practices or things should be being followed. But don't take just my word for it. In the same books, McConnell talks about a couple of studies that other companies did with their stuff that I want to talk a little bit more about. So IBM, when they started doing code reviews, they found that for every hour they spent doing code review, it saved about 100 hours, 100 worth of related work. So if we put some real numbers to that, that's assuming that for like every $50 that they invested, they were saving $5,000. I would love to have that type of return on investment, right? That's crazy. Well, let's take a look at another way. Raytheon found that when they were doing a project, 40% of that project's cost was due to rework. Literally just not building the right thing, or they built it, people tried it out, it's like, it's not quite right. But once they started doing code reviews, it went from 40% of the total project cost to 20%. So they cut that thing in half. right? So for $1 million project, instead of spending 400 grand on bug fixes, only spent 200 grand. And for those in the room, talk to your manager or your team lead about if they're interested in reducing their project cost totally by 20% or by 50%, depending on how you want to look at it. I can assure you they're going to be interested in knowing how they're doing it. So I'm going to take a pause here for a second, right? Because we've been talking about code reviews in a positive manner, a negative manner, and some professional reasons why we're doing it, right? Because at the end of the day, we are professionals, right? I draw a paycheck to make sure that I'm delivering the right software for my customers and for my clients, and you all do as well, which means part of that responsibility is looking out for your employer or for your client that you're working with. But it's not always just about the business side. How can code reviews help you as the individual, right? Let's take a minute and talk about this. So I don't know about you, but most people got their start as engineering essentially not knowing what the heck they're doing, right? You probably either were self-taught, a boot camp grad, maybe you went to college, what have you, and you learned some stuff. You learned some syntax, you learned what an array is, you learned about an if statement, maybe loops, and that's all well and good. But when you got your first job, you had to learn how to actually combine the stuff to build things, right? It's not so much that you know what an if statement is or what an array is, but it's how to use them and how to apply them directly. And the way you did that is because you were exposed to a lot of different situations, right? You worked and learned from others. We're pretty lucky, right? It's not like we're the first group of software engineers to ever come out and do this stuff, right? There's people who've done this before, so we can lean on that and gain that expertise, and in return, pass that along to the next generation. And if you don't think getting all that experience and different ways to think about stuff is important, let me give you a hypothetical situation here. So I don't know if you've heard, but hiring software engineers is kind of a hot market right now. So let's say that you're looking to hire an engineer and you've got two different resumes to look at, engineer A and engineer B. And when we look at engineer A, man, they've got some decent years of experience, man. They've been doing this for 5 years. Okay, so probably a little bit safe doing this work. But once you start digging into that resume and checking with that engineer, what you're realizing is that they've really been doing the same thing that entire time, working on the same project, building out the same widgets, using the same skills and techniques they learned, first couple days on the job, and haven't really grown. You talk to engineer B, though, they've got 2 years of experience, so a little bit less, but they seem to have worked on a mix of things, right? They've done some database development, maybe some front-end development as well. They've got some experience building up unit testing, maybe some automation, implementing code reviews, all sorts of such, right? And between these two, which engineer do you think is going to have a better success of getting hired on somewhere else? Do you think it's going to be engineer A or engineer B? In my mind, it's going to be engineer B, right? Because even though there's going to be a little bit of a curve to get them up to speed, the growth trajectory is much higher, right? They've already proven that they know how to build up new stuff, that they know how to apply new techniques. This also usually implies they're somewhat coachable, which if I'm hiring an engineer, I absolutely want them to be coachable. If not, this probably isn't going to work out very well, right? Because they may be stuck in their own ways. So we've talked a little bit about growing your skill set and why learning all this stuff is important. But let's take this one step further and talk a little bit about career safety. So story time from my perspective. Early on in my career, I was working at a place where I felt like I actually wasn't going to make it as a software engineer. It was one of the first jobs I ever had. It was very stressful. I felt like I was never doing anything right. And it took me a long time to get out of that job and somewhere that was a lot safer. I swore to myself then I would never find myself in that situation again, in a spot where I couldn't change jobs. So when I thought about code reviews from that perspective, they actually give you quite a bit of a safety net in two ways. So the first way they're going to give you some safety is because it helps you become more valuable. The second way is actually being employable. And when you're both valuable and employable, that's job security. Man, you ain't got to worry about your current job or getting a new job. If you've got both of these figured out, you're in a good spot. So when we're talking about being valuable, though, we're talking about things like knowing more skills and techniques. When your work is being critiqued and when you can critique other people's work, you're learning about how they approach things, how they think about stuff. You're learning new ways to build software, things to be considering about. That's valuable, right? because now that you know that, your employer is going to want to make sure that you're around if needed. So you may be one of the last people to be let go in case there's layoffs, right? Usually if you're able to do code reviews and work with others, that means you've built up relationships, right? If I could only hire one person, I would try to hire the smartest person I could. But if I can hire more than one person, I'm going to hire people that know how to work with each other, because the smart jerk, their usefulness is quickly overcast by a team that actually knows how to work together. And code reviews is a great way to figure out people who can work with each other and coach that up as needed. The other thing is, man, you do those code reviews, you're learning about how different parts of the system work. Usually means you're leveling up in your domain knowledge, right? The most effective engineers are the ones who know how to build stuff technically, but also know the problem domain. Code reviews are a great way of handling that, and you'll actually see that later on in this presentation. From an employable perspective, though, man, it's a lot easier to get a job when you have demonstrable skills and techniques. And you can talk about that because you've learned it at your previous gig, right? So you can actually speak about it and go a little bit in detail because you've done the code reviews, right? Something else I totally purport is it's super easy to teach tech. It's a lot easier to teach someone the technology than it is to teach people skills, right? If I've got someone who can do development, I can teach them C#. I can teach them LINQ. I can teach them inheritance. I can teach them dependency injection and version control containers. Man, that's easily teachable. That's not hard. There's tons of tutorials out there. It's really hard to teach people skills, right? That's not simple rote memorization anymore. That's applied effort. You've got to know how to pick that up. And code reviews is a great way to figure out how to teach them those people skills. So we've kind of talked about some of the reasons, both professionally and personally, why you may want to do code reviews. I'm going to kind of go ahead and shift into some anti-patterns. But before I do that, I think Joe's got a question in the chat.
Yeah.
So let me pause here. Joe, what you got?
I do. And I just wanted to kind of level set the discussion here a little bit too. When we're talking about code reviews, are we talking about developers who are familiar with the code they're reviewing, as in they've worked in that code, or haven't, or both? What's the expectation that the reviewers would have in terms of awareness of the code they're looking at?
Yeah, so that's great. I actually like it both. You want to have a little bit of mix of both, because when you have somebody reviewing the code that's very familiar with it, they're going to maybe keep an eye out for some idiosyncrasies with that code base. But for the most part, if there's something that's a little bit weird, they're not going to notice it because it's always been there, right? They're blind to it. When you get someone in there, though, that maybe hasn't seen this code base before or is not used to that area, they're going to ask tons of questions. They're going to ask a lot more why. Why is it built out this way? Why is it kind of hanging this way? I saw you approach it this way, but why are we doing that? When you start asking those why questions, that's when you start having conversations. That's when you start opening things up. So I actually like having a mix of both on the reviews.
Do you envision the code reviews always being group meetings, or do you envision them more like a PR where you might make a comment or two in the code, but you don't ever really talk to the developer real time?
Great question. The perfect answer is it depends. So for the team I lead right now, we actually do a mix of both. So for example, my team has been working as 2 separate squads to go implement a feature. But every time one squad gets something done, a member from that squad and then a member from the second squad actually do the code reviews. And if someone's got a lot of questions, cool, we make that synchronous. Let's go hop on a call, let's walk it through, right? Make sure you understand and ask those questions. But if it's some stuff that's maybe more local in scope, you can just leave that as a comment on the PR and address it that way. The thing you want to make careful of, though, is that if you're starting to see a lot of back and forth chatter, hop on a call, make that synchronous, because obviously there's something a little bit bigger going on. Does that help?
Yeah. I just wanted to get a mental picture of the environment in which you were talking about.
Yeah. One thing that we'll talk a little bit later on is about some things to keep in mind when you're trying to implement code reviews at a company, because depending on your engineering setup, who you're working with, whether you've got onshore versus nearshore, contractors, what have you, that can dictate a few things.
Okay.
Yeah, I can't give you a one-size-fit-all approach, but I can give you some advice on what not to do.
Okay.
which is what we're about to roll into. So hopefully that helps.
Sure. Well, thank you very much for taking a break and answering those questions.
Yeah, no, thanks for putting something in the chat. That helps me out. Otherwise, I'll just keep rambling for a bit. So one anti-pattern I see a lot of places try to do, and I caution you not to do, is try not to submit a novel to review. And we all joke and realize that a 20,000 line long PR is probably a bit excessive. Right, a PR that's got 500 change files is probably too big. But how big is too big? Right? Let's dig into that a little bit. So I think back in 2011 or so, IBM partnered up with SmartBear and Cisco to try to determine some best practices for code reviews. And they actually published a report as the 11 best practices for code review. And SmartBear still does an annual report of this on some best practices for doing code review. But in the initial version, this was a study that was done that involved 2,500 code reviews with 50 developers and over 3 million lines of code developed at Cisco. So not maybe the most representative example for all software development in all software industries, but not a bad place to start. And in this study, they found a couple of patterns to be aware of. So one thing that came out of it was this idea of defect density versus lines of code. So this is kind of a scary looking chart here, but here's how to read it. What they found is once you got to 200 lines of code, the effectiveness of the review about dropped in half. And then once you got to this 400 lines of code, it dropped even more. And then once you got to 700 lines, 900 lines of code, you might as well not even do a code review. It's too much. Not able to keep track of it. And so based on what they had found, here was kind of their rules of thumb that they were wanting to follow. So some recommendations they have is you don't really want to go faster than 500 lines of code an hour. And that kind of makes sense, right? Especially if it's non-generated code. And let me be clear, right? When we're talking about lines of code, we're talking about stuff that was handwritten, not like designer file changes or something along those lines. But no faster than 500 lines of code an hour. And when you're doing code reviews, you typically don't want to be doing that for more than an hour at a time. Question for the group, why do you think that one may be the case? It's a little bit maybe not so obvious, but anyone who is a tech lead or leader might know it. How often do you get an hour plus of uninterrupted time? No one coming by and saying, hey, Cameron, do you have 10 minutes? I need to chat with you about a thing. Probably not often, right? And every time you get pulled in one of those conversations, you have to kind of rebuild back up the mental model you was looking at for the most part, right? So, but Cameron, I hear you say, sometimes I have to make a massive amount of changes, right? I've got to do it, right? Just the architecture, the application working, whatever reason, I got to do it. Cool, we can. But instead of doing it all as this one giant chunk, let's break it down to something a little bit more manageable. So let's talk about some different ways you can do that. So when I deal with these problems, hey, I got a large amount of work that we've got to do, there's really two different approaches you can take. So the first approach is breaking down the work items to smaller items. And that's usually because someone's giving you this massive pile of work, didn't realize how big of a pile it was, and you have to break it down and something that's a little more deliverable. And then the second approach is branch of branches, which we'll talk about in a second. But when we're breaking down these work items to smaller pieces, right, the first approach is this vertical slicing, and the second approach is horizontal slicing. For vertical slicing, instead of, let's say we're building out a new screen, right? So a new screen where somebody can enter in some data, save it, kind of typical CRUD operations. So in vertical slicing, I'm going to say, well, I'm going to add this new text box and add this new thing to the API, and then add this new thing to the database, and then I can deliver that one chunk like that. So there's always a little bit of functionality. And it works great when the vertical slices lend itself pretty well to that. Web development tends to do pretty well with this. Horizontal slicing, on the other hand, is more of your layered approach where, okay, I'm going to do all the database work first, and then now that I've got all the database work first, then I get to the API, then I can get to the UI, and then so on and so forth. You can still do development that way, and there's nothing wrong with it. The downside, though, is you can't really see anything truly working end to end until you get to the very end. I found that when working in layered applications, horizontal slicing tends to be a little more powerful. But let's say that for whatever reason, you can't go with either, right? It's just dead set. Hey, we can't even get this merged in until the whole feature's done. Then we're going to look at branch of branches. And so this is assuming that you're using some type of either Git, though you can do this with TFS, the terminology would just be slightly different. But what you could do is you're going to create a branch called work in progress from the trunk. Once you've created that branch, you can start creating feature branches from that work in progress and start doing those small pieces of work, right? And as you're doing that, you're going to be reviewing those smaller feature branches as needed, right? As you review those feature branches, those smaller things being reviewed, you're going to merge that back into the WIP. And then once everything for that feature, for that bigger piece of work is done, you can now merge the work in progress into trunk. This is kind of like your last approach. I do not recommend starting off with this unless you have literally no other choice. Because the problem you're going to run into is that the longer that your WIP branch is separated from trunk, the more drift you may get into your trunk, right, of other teams doing work. So if you go down this route, be very careful how you do this and make sure it's not long living. I would say if it's really long living, more than 2 weeks, 3 weeks, you probably got an issue here. And more likely your feature wasn't broken down small enough. So I'm going to take a pause here, see if there's any questions in the chat. Does not look like it, so we will go ahead and keep moving. The other thing I encourage teams to do is when you're providing feedback, let's set some context, right? So, oh, sorry, I'm going to stop. I see the question came through really quick. Hey, Rich, what's your question? Maybe Rich is on mute, or he's going to hold on to it for later. So no worries, we'll just keep moving then. Well, actually, things coming in chat here. So Rich, if it's easier, why don't you come off mute and ask your question, my friend? Okay, so it seems like the question is, how does vertical slicing work well with Agile? Yeah, so I think vertical slicing works great with Agile, right? Because when we think about this new piece of functionality, right, Agile's thing has always been, let's deliver value. And when we say deliver value, it's usually value to the user or to the client, right? When I think of horizontal slicing, that doesn't really tend to lend itself value because, okay, cool, you've done all the database work, but the user can't do anything with that, right? For vertical slicing, when I think about, okay, I've got to implement this new screen, maybe the first PR is, okay, let's just get a screen hooked up and maybe with just placeholder data. Okay, cool. We can go ahead and get that deployed and it can start looking at some things. Or we can then say, all right, well, we've got this screen. We're going to go ahead and get this one piece of data from the API. We'll go ahead and get that implemented, and then we'll go ahead and get that wired up. And then we deliver that whole thing. And so the first step is, all right, now I've got a screen with a little bit of data coming back. It's not everything you want, but at least the user has something to work with. We can now iterate on this, right? The concern with horizontal slicing is if I do all the database and then all the API, then all the front end, all my iteration is going to happen at the front end layer because that's when the user is really going to be able to touch it. So if I've messed up in the API or database but didn't really figure it out to the UI, I've got problems. So that's kind of my response to that question. It's a great question, though. So picking back up from where we're at, we were talking about feedback and making sure we've set some context there. And the reason why that's kind of important is because we're going to look at code where someone's written something and you're going to think, man, that's not how I would have done it, right? Or what is this code supposed to do? And you're really just perplexed, right? And maybe you're going to say, what in the world were they thinking? That's totally normal, because when you see something that you're not used to, you're going to naturally want to put up your guard and maybe be a little bit derisive about it. So the question I propose is the goal to have everyone code the same? No, right? Remember, we're not writing code just so that we're writing code. We're writing code because it's to solve a problem. So the thing is, though, is that we don't want to just ship code over the wall, right? We just don't want to ship it down the lane. We want to make sure it's going well. So if we have concerns about it, we need to make sure we provide meaningful feedback. And kind of the recipe I'm going to recommend to you is, when you're doing your feedback like that, is if you've got suggestions, actually use the words when, what, and why. I have found that when you add these three things in, especially when working with new engineers or new engineers to the code base, you really open up some dialogue. Let me show you. So let's say I've got some C# code here, and it's terribly written, but that's okay. The thing that's caught your attention in this code review is this piece, where you're like, that's weird. This method says it's going to return back a list of customers, but if there's nothing in the database, we're going to return null. That seems weird. That seems off. So your first impression might be to say, hey, don't use nulls. Okay, but then how do I deal with this? Right? There's not enough context here. What are you proposing? What do you want me to do instead? Right? Throw an exception? I don't know what to do. Instead, we can beef this up a little bit better and say something like, hey, we shouldn't return null when retrieving a list of records from the database and there aren't any. Okay, cool. So the context here is like, hey, I'm getting stuff from the database. There's not any. I shouldn't return null. All right. Well, what are you proposing? A little bit wordier, but let's break this down. Hey, when we're doing this thing, returning records from the database and there aren't any, here's what we should do. We should return an empty list. And why should we do it? Because, hey, once we return back an empty list, we don't have to add all this error handling code. We can just use the built-in list operators. I'm not advocating that all your PR comments have to be this wordy. I'm advocating, though, putting the context and the why behind your suggestion is powerful, because now you can actually have a dialogue, right? You can have the conversation. Here's what I found, and I'll use that previous example. Maybe I tell that engineer, hey, I see you're returning null. Why don't you just return an empty list? Oh, Cameron, that's a great question. Yeah, the reason why you don't want to return back an empty list is because in the UI, we treat an empty list as a very specific thing instead of a null. And then I go, wait a minute, why? Why are we doing that? And now we're opening up a conversation. I'm trying to figure out why we're treating this differently in the front end. So maybe I've opened up a can of worms, or maybe I'm about to increase my understanding of how the application's working. Both pretty good things to know at this level, right? And we're having that conversation because I've put the context there. Hey, we shouldn't do it because of this. Yep, I hear you, but here's something that you probably didn't consider. So to combine on that, when I receive a code review, and when you might receive one, it's totally normal to be nervous or anxious about having your work reviewed, right? Because you've been working on this thing for a while, especially if maybe you're at a new job, right? New team. You want to make sure that you look like you know what you're doing. Imposter syndrome may be a concern for you. So it's normal to be nervous or anxious about having your work reviewed. And in fact, Cyanide and Happiness has even made a comic about it, because of course they have. So I won't read every single word, but the gist of it is that you've got two engineers. The first engineer is lamenting like, man, my boss says I need to completely rewrite my code. And the other engineer is doing their best, saying, hey, that's okay. It couldn't be that bad. And the first engineer goes, great. Why don't you highlight everything in my code that you think seems stupid? And the second engineer gets really sad, really bummed, and then highlights the first engineer's face. That's not great, right? Because we kind of work in stressful stuff. And so being called stupid or whatnot doesn't make me feel great, probably doesn't make you feel great. So to help remove some of the anxiety about this, one thing I recommend doing is reinforcing this idea of joint ownership. And you can do that in your comments pretty easily. Instead of saying like, hey, what should you do when there are no records in the database? Hey, what should we do when there are no records in the database? And this might seem a little bit unusual, but I found this to be really helpful because it lets the other engineer know, like, hey man, I'm caring about this code because I gotta support it too, right? You're not the only one working this code base. It's collective ownership. So I care that we're doing good work, but I'm not going to put all the onus on you. I want to have those conversations. I want to make sure we drive to the right thing. And that's because most companies, not any one developer owns the code base, right? You don't want to be in that experience. So you kind of want to make sure you reinforce that collective ownership. And combining onto that, you might find yourselves in situations where you're looking at code and you're just really frustrated, right? You're like, why are they doing this? I'm kind of angry at them, right? Because they should know better, what have you. And so you've seen some code, and maybe it's a for loop, and you're like, man, this for loop is garbage. What in the world were you thinking? Nope. It might make you feel better, but you're going to be kind of seen as a jerk. Here's a different way of phrasing it. Admit ignorance. Just admit the fact that you don't quite understand it. So instead of saying, hey, this for loop was garbage, you could say something like, hey, I'm having issues understanding this loop. Can you step me through what you're trying to do? And here's what you'll find. That conversation will go one of two ways. Either as you're walking it through with the other engineer, they're going to say, you know what? Cameron's pretty smart. Like, Cameron's good at what he does. If he's having issues understanding this code, maybe this is a lot more complicated, or maybe I didn't do a great job of clearing this up as I should have. Sweet. Code quality improvement. Nice. The second approach may be, maybe I'm just not as good as I thought, right? Maybe they're using some link operations, for example, and I'm like, oh man, I've never seen those before, so that's why it was confusing me. Sweet. I'm going to level up today. But it's really hard to level up or have those conversations if you essentially say, hey, this code's garbage, do better. Right? So you may have been picking up on a theme here that I keep talking about team camaraderie and like we should be a team about this and why. The big reason is because there is a thing known as the bus factor, or also known as the lottery factor. For those of you not familiar with that concept, the idea behind it is how many people could leave a project before the project is in danger of not being able to be completed. And so story time here. At an earlier gig I worked at, we had to build this desktop installer for a product, right? We were building out the installer, and it's because it was for federal government work, whatever. And so I had developed a way to build out the installer for the app. So the way it would work is client says they want a new version of our software. I would go create the desktop installer that would then get pressed. Yep, got pressed to a disk, like burn on their old school, and then shipped to the client, and everything was hunky-dory. Well, I did the silly thing of going on vacation with the family, right? I've been working really hard, went on vacation. Lo and behold, I'm in line at wherever I was at, and I get a phone call. Hey, Cameron. Client found a massive issue in our software. Have to get it fixed. Got to create an installer. We don't know how to do that. Can you walk us through? Didn't have my laptop on me. It was back at the hotel room, like an hour plus away. I was kind of on with my family, so it's this weird, like, hey, we're out doing fun stuff. So I had to go and get them squared away. But the problem and the lesson I learned is I had never really taught or walked through anyone about that code I written for generating the installer. So when they had issues doing it, they didn't know how to fix it or how to resolve it or how to do anything because they weren't there when the magic was cast. Code reviews are a great way of doing that because you're now letting someone in on the secret of how that stuff works. So at this point, we've talked a bit about some things that we should be doing in code reviews, some things we shouldn't be doing. I'm going to kind of pivot now to like, what are some things I look for in a code review? So this is just my opinion, right? You could follow this, you cannot, doesn't matter to me, but here's some things I keep an eye on. So for me, when I'm looking at code and software, there's 4 main buckets: correctness, readability, maintainability, and style, roughly in this order, right? And we're going to explore each of these a little bit deeper on like what I mean. So when we're talking about correctness, I'm really talking about our inputs handled correctly, right? Are we given known inputs? Are we getting the right answers? If we've got what about other interesting edge cases, right? Nulls, arrays, negative numbers. If I'm doing stuff with networks, what happens if I cut the network activity? I'm just trying to see, like, are we handling these things right? And it can sometimes feel a little bit like a Rube Goldberg machine, right? Because I'm trying to exercise all the different little things here to make sure, like, okay, is this really working? But a lot of this stuff is happy path. Let's say that something fails. Did it fail correctly, right? Did the app crash? Sometimes that's the right answer. Yeah, the software is in such a state that it should absolutely crash before we do something bad to the data or what have you. Other times, though, we just need to present the user with a message. Okay, well, does that message make sense? For example, if we lose connection to the database and I do a message prompt telling the user, hey, we lost connection to the database, might make sense if the person using the software is an engineer or someone technical. But if I'm working on accounting software and an accountant gets that message, yeah, that's not a great failure condition, right? That's not the right way to handle that. So those are some things I'm kind of looking for when we're talking about correctness there. When we talk about readability, we're really talking about what in the world's going on. And the thing about readability is it's determined by your team, right? If I've got a bunch of senior engineers that are really good at .NET, they may be doing some really cool reflection, dynamic invocation of things on the fly, and that's just totally normal for them. If I have a team of more newer engineers, more green engineers, they're going to look at that and get very confused about how any of that works. So my recommendation for what readability is, you want clear code versus clever code, right? I want the code to be written in such a way that someone can pick it up and run with it without too much hassle, right? But in the situations where we have to write more clever code, what I really want to make sure is we're leveling up people along the way. For example, yeah, maybe I've got some really cool for loops here and they're double nested, whatever, and it's doing all the stuff it needs. And it's clear, right? You can follow it. But I may just go ahead and refactor that to LINQ because LINQ's a lot more clear in my intent. But if no one on my team knows LINQ, then I need to level them up first. So what this is not is coding to the lowest skill level. That's totally not what this is. It's writing the code that's needed to solve the problem clearly, right? So code simple enough to solve the problem. And one of my favorite comics about this is you can measure code quality by the WTFs per minute. So hopefully none of you all are working in a code base that makes you quite go like the door on the right. If so, let me know. Maybe we can figure something out for you. Maintainability. How easy is it to make change? Pro tip, code's always changing. Applications are always in flux. If they're not, that means your application's most likely dead, and that may be a dead product, which could be a bad thing for you, right? So if code's always changing, I want to make sure that we're designing code that's somewhat easy to change here. And what I mean by that is easy changes are easy to make. Here's a great example. Let's say that we're working on an ordering system. And one of the things that you can do when you make an order is that you'll get some type of notification that, hey, your order is shipped. So let's say we have such a system and we've got configured that you get email notifications. And your product owner comes down and says, hey, email notifications are cool, but is there a way we can also get like text notifications and configure that'd be awesome? If you had originally got the email notifications working in, let's say, a month and a half, just picked a number out of thin air, I don't think it would take you that long, but let's say a month and a half, and when they ask for text notifications, you say 4 months, that should probably raise some eyebrows, right? Because wait a minute, this is roughly the same thing, just a different medium. Why is it that much longer? Should be an easy change, right? Another example is following that ordering example. Let's say that you're sending emails and someone's like, oh yeah, I want to switch out the header for this to be, instead of normal font type, I want this to be bold. Okay, well, that sounds like that should be a 1-day change, maybe 2. If someone says 2 weeks, 2 weeks, right? Obviously there's some maintainability issues here. So that's what we're talking about when we're talking about easy changes should be easy. And depending on the code base, what I'm looking for are certain patterns or architectures being followed, right? If I'm in an OO code base, I may be looking for things like solid principle at apply, right? Or maybe hexagonal architecture. If I'm looking at other types of code bases, I'm really making sure of things of, hey, we're not writing the same code 20 different ways. Hey, we're not over-engineering or gold plating, and various. And that's what some of those acronyms are staying there for on those regards. But it's really, are we following the patterns and architectures that this application should be? Is kind of what I'm looking for there. And if not, if we've deviated, I'm going to ask questions. Okay, cool, we deviated. Is there a really strong use case for that? And last, style. Does this code look like it should? So for example, does this C# code look like a C# developer wrote it, or does it look like a Ruby developer who was told to write C# write this code? This is especially important when you have new engineers to the language, or new engineers to the code base, or they've made tech stack changes, what have you. For example, when I onboard engineers, it's not uncommon to onboard engineers from Java. So when they go to write C#, they write a lot of their code with arrays, and their method naming is camel cased, right? Because they're following all the Java idioms, and as a .NET developer, you look at it and go, huh, that's a bit weird, right? So when I'm looking at style, it's things like naming conventions, proper coding constructs. So instead of using arrays, probably should be using lists, unless there's some weird API reason why you need arrays, and project structures, right? I highly encourage you all not to be doing this by hand. Ideally, you're using things like linters and style guides to help enforce these / automatically fix this stuff. But I do still call it out. One thing you may have noted, because I just now mentioned styles and style guides and linters, is I've not really talked about tools a whole heck of a lot, have I? Right? I've not sat down and mentioned you should be using, even GitHub. Right, I said source control, which if you're not using source control, I'm really curious how you're doing code reviews, but I didn't mention a tool. And there's a big reason why. What I find is that when companies are implementing code review processes or trying to figure it out, they just buy a ton of tools, hand it to engineers, and tell them to go figure it out. Wrong way. When you do it that way, you're letting your tools dictate the process. It needs to be the other way around. Figure out what process works for you and your company, then choose the tools that help you automate that process. A colleague of mine, Jeff Mazeroff, has a blog post. Pretty much it's like how to think about code reviews. The premise behind this blog post was Jeff was working at a company that was trying to get like one of the ISO 9000 certifications. And one of the things of that is setting up code reviews. So in this blog post, Jeff outlines a ton of stuff about what he thought about when implementing a code review process. If you're looking to implement code reviews at your company, I cannot recommend that blog post highly enough. If you were to use the links I posted at the very beginning of the presentation or in this chat, you'll see the link to that blog post. I found it to be very insightful when standing up these types of things. So, okay, we've talked a little bit about what I look for in a code review. Let's actually walk through how I would lead a code review, or actually walk through one. And so let's say we're doing a bug fix. So the first thing I'm going to do when I'm going through a code review, or the first thing I'm going to look for is framing. What is the problem? And so when I'm describing the problem, I want to focus on user interactions as much as possible and make sure I'm using domain terminology, right? So instead of saying something like, hey, yeah, when I click the submit button on the add item to order module, it causes a foreign key constraint violation in the database. All of those words may be technically true, but man, it is garbage when it actually talks about what's really the problem, right? What stopped working? What's busted? What's broken, right? That's really what we need to know. Hey, when I add an item to my order, it causes an error when submitting the order for approval. Okay, yeah. From a user perspective, that makes, I now understand what the problem is. I can't add items to my order to be approved because it causes a problem. Sweet. So now that I understand from a user experience, like what the problem is, I got some questions I'm going to make sure I can do. Can we consistently reproduce the issue, right? If so, that means we have a good way of knowing when we've actually fixed it, right? Now I know not all bugs can be reproduced, right? Sometimes there's race conditions and errors, but I'm still going to ask the question, can we actually consistently repro? The next thing I'm going to look for is, have we found the root cause? So when working with new engineers, I find, and even the experienced ones that maybe are a little bit full of themselves and they think they know exactly what's happened, is they'll find symptoms but not the root cause. And let me give you an example. So, hey, yeah, the problem is that this variable was null, so we just added a null check that if it's null, not do the workflow. Cool, that solves the exception from happening, but is that really the problem? No, that wasn't the problem. In this case, the problem was, hey, yeah, the reason why this variable is null is because this list of valid items, it just hadn't been populated yet. Because that list hadn't been populated yet, this variable will become null, and that's what causes the issue. So in this workflow, adding a null check isn't the right solution. The solution is we got to figure out why is valid items not being populated in a timely manner. That's really the root cause. That's really the thing we need to go dig into, right? And now that I understand the problem and kind of what some of the root cause is, we can actually walk through the fix. And there's really two ways you can do it. One is top down, the other one's bottom up. Top down's great when you want to go from the user experience. So something like, okay, cool. So I've started an order. I've clicked on this button, add an item. Well, when I clicked on that button, it goes into our add item to order module. And when we get to this module, it talks to the repository, and the repository does so on and so forth. And you work your way down the stack. And that approach works great, especially if it's like a user workflow, because that kind of lends itself really well. In other styles of code bases, maybe you're working on a distributed system, maybe some type of message queuing system, what have you, a bottom-up approach may make sense, where you can go, okay, well, so the problem is that this process failed, and because this process failed, now this system didn't know how to handle that, and because this system didn't know how to handle it, so on and so forth. And you can work your way back up on how it may have exploded or broken for the user. Either approach is great, just pick one that makes sense for your use case. Pro tip, have you ever had that feeling that you've got a solution in your PR, it works, solves the problem, but you're like, this is a bit weird. Like it technically works, but it's a bit awkward. I wish there was a better way. Call it out in your code review, right? One of the life hacks I use when I do code reviews, when I create PRs, is I'll call out the areas for a reviewer to take a look at and be like, hey, this kind of works, and I tried these things to clean it up, but it still didn't seem right. Do you have any suggestions? And this is powerful because A, you're helping your code reviewer actually focus on the thing you would like them to spend some time on. But second of all, this helps you level up on better refactoring skills, right? Because you're seeing another engineer take on it. And going back to the question from Joe earlier, if it's going to be a little bit more of an involved refactor, go ahead and pair on it. Right, go and pull up the code and actually walk through it so you can level up. Maybe you're about to learn a new design pattern or a new API or something in the .NET framework that you weren't aware of. Oh goodness! So we've walked through the use flow. We've figured out what the problem is, the root cause. We're now starting to really look at the solution, right? So we're going to spend quite a bit of our time here. And we're going to provide feedback on the work done, some ideas for improvement. Remember, we're going to use some context with when, what, and why. And we're going to make sure that the code's maintainable, readable, adequate quality, follows correct style, all of those things that we talked about earlier. Right, and so you're going to spend some time here, right? This is not, 20 seconds looks good to me. You're going to pull it down, actually run it, compile it, poke at it a little bit, and say, like, okay, this kind of makes sense to me. I can understand why this would flow this way. Something I see engineers do a lot is that they just look at the PR in GitHub or whatever PR review tool and not actually ever pull it down and look at it in their editor. And that's kind of a shame because you don't really ever see how it hangs from that perspective. All right, you've looked at the code. The code looks pretty solid, but we need to verify it, right? We actually want to make sure this thing is fixed. So we're going to demonstrate the fix by using the repro steps from before. Bonus points if you actually have a unit test that was failing because the bug exists. Right, this is especially a powerful technique if you've got a code base that's a little bit older or doesn't have much of an automated test suite. This could be a really huge help. Because if for no other reason, you're going to make sure the bug doesn't happen anymore because you got a unit test that failed because the bug exists. Other thing that happens when you're doing the verification, especially from the UI layer, is now that you know what's happened at the code level, you can now start thinking about, oh man, if they had to make code in that module, I wonder if these other workflows are now impacted. Let me go poke and prod at this a little bit. And so you can do that here. So that's kind of it from a code review, how I lead through. And like I mentioned before, right, if there's a lot of conversations, I'll make it synchronous. So I'll grab a couple people, I'll hop on the call, we'll go review it. But y'all, that's kind of where we're at. We're going to wrap up here a little bit, kind of put a bow on this. So we covered a bunch this evening, right? We talked a little bit about why code reviews are important, both from a professional perspective and from a career, right? It's good for you professionally and personally there. We talked about some common anti-patterns of code reviews and some mitigation strategies you can use instead to make sure that doesn't happen. Spent a little bit of time to talk about what I look for in a code review personally, and then we even walk through how I would perform a code review and some things to take a look at. As I mentioned before, if you want to look about some of the blog posts I've talked about or books, things like that, all of those links can be found on my website at the QR code below and the URL listed. Otherwise, that's all I had for this evening. I appreciate you all spending your time with me, talk about code reviews. I really appreciate it. Thank you.
Hey, Cameron, this is Joe again.
Yeah.
Have you ever had a developer who was just phobic of code reviews? Just, they start shaking the moment you mention code review. And how did you get them past that?
So I've never had an engineer get shaking on a code review. That is a big extreme.
I might have exaggerated a little bit, but
no. So what I try to do is I remember this as a person, right? So I'm going to chop them and try to figure out, like, why is there so much nervousness? Is it because they've had a lot of bad experiences? Is it because there's someone they have friction with? And that's what they're actually concerned about. Steven, I think we were chatting earlier about, or someone had mentioned about, like, oh yeah, I'm getting my code reviewed by a peer, make sure it's good. Well, if that person doesn't have great people skills and they just kept saying, like, hey, your code sucks, you suck, you're not really great at your job, I probably would also be phobic. So I want to make sure and figure that out. And then if they're still really nervous, I'll actually step through with them on that, right? Because I'm pretty good at giving code reviews, and I can really be very gentle, right, on the comments and help build that up and try to really reinforce that. Hey, the comments about the code they're not comments about you, right? They're the comments about the code itself, not necessarily you as a person. And the other thing is I'll have them review my work, right? I'm not perfect either, right? And show them, like, yeah, it's okay to make mistakes. It's all good. But it's really just trying to relieve that stress and really figuring out what the cause of that stress is and then removing it if it's a person or something like that. I've never had to deal quite with, like, a toxic situation with that, but I have worked with other engineers who've had to deal with that for their teams.
Okay.
Did that answer your question? I want to make sure I actually answered it.
Yeah, I think it did answer your my question as best as you can, and it's a case of every situation is different, right?
Yeah, and really it's what's causing it. If it's been a negative experience, that's somewhat coachable. If it is an internal thing, right, the best thing you can really do is give them some time, let them level up. But what you don't want to do is just give them a free pass, right? You don't want to be like, all right, cool, your code never has to be reviewed, right? Mm-hmm. That's the absolute worst thing you want to do.
Mm-hmm. Mm-hmm. So you have to find a way to bring them into the fold.
Yeah, and even if it's just really simple stuff, right? The other thing too, and I've showed call this out in the presentation, so I appreciate you giving me the opportunity to say it. You don't always have to pick out the bad stuff. Feel free to say, hey, really love that refactor you did here. Oh man, that's a really cool way of doing this. I hadn't thought about doing it that way. Feel free to let them know the spots, the stuff that they did well, right? That'll kind of help with some of the confidence issues there.
Mm-hmm.
I just want to say thanks, Cameron. This was really, really good. I liked your the admit ignorance when you don't understand what the code is doing. I think that's something that I know that some people, like myself included, I know at times I've just been like, okay, well, I think they know it better than I do, so this sounds good, and just done that more like a rubber stamp approval. And I think that's a good call out to spend that time with people to really say, let's get on a call together and understand it and stuff. So it's very cool. I think it's a good tip.
I appreciate that feedback there, especially the admitting ignorance. I don't know if you're a senior engineer or what your role is at your current company, but what I found is when the senior engineers and the experienced people say like, hey, yeah, I totally don't understand that. Can we walk through? It empowers and encourages your associate engineers to also start doing that.
Yeah.
Because they go, oh, the senior engineer is able to do that. The staff engineer is doing that. Well, then heck, why can't I be saying that? Because if they don't understand it, cool, I should probably be asking those questions.
Yeah, that's what exactly right. That's why I think as I am like considered that senior role, and so I think I can make a bigger difference to the rest of the team. So that's really good. Yeah. I would also say, I guess, I'm adding like something that I think I struggle with is also the making the PR smaller. So I think those are some good like approaches, especially that. I know you said like the branch of branches is your like last resort, but I can see where like that's an interesting technique to get us talk to more as like a gateway to me, maybe, because it's hard to get people to break up things into smaller stuff. But if we say, well, no, you actually be doing the final merge, we'll just do this like work in progress branch, and let's break it into smaller PRs for easier review, but you'll still be doing the final push into main, our trunk with the final feature. So I think that's and then maybe from that you could then figure out how to do something like vertical slicing, stuff like that.
Yeah, because what you can then start opening that conversation up to is most teams I work with that have issues with vertical slicing is that they don't know how to deliver functionality in piecemeal fashions or in a way that is safe to go to production when it's not fully working. So using things like feature flags. At the current team I'm working with right now, they didn't really have a whole lot of experience with feature flags. So when I introduced like, hey, let's do vertical slicing, there was like, but Cameron, we can't just deploy the front end without the back end. Things are going to blow up. I'm like, no. Here's some ways we can actually do that in such a way that we still get feedback.
Yep, the feature flags are awesome for that decoupling deployments from releases. And
bingo.
Yeah, and but it's still getting people to kind of buy into it and stuff. It's the hardest part, when they're so used to it that way. So, yeah.
Yeah. The thing I'm going to encourage is that if you have, if you're a senior engineer, right, you have some respect. Use that, right? That's kind of one of the reasons why you're there is to help make sure that your teams are doing the right things. And so if that means making people uncomfortable a little bit, that's okay. But then it's up to you to show them like, yeah, we're going to be uncomfortable for a little bit of time, but that's all right. Let me show you how it's going to actually be faster for us.
Awesome. But give me a lot of stuff to talk about in retro. So.
For whoever's team Adam works with, I'm sorry. I was going to throw it out there.
No, they'll be better for it, right, Cameron? That's the idea.
No, absolutely. All right. Any other questions or comments?
Oh, that was good. Good coverage.
Yeah, I definitely enjoyed it.
Well, thank you very much, Cameron.
Yeah, thanks, everybody. I appreciate it. I'll stop the screen share real quick.
Yep. So in the chat, I dropped the link to the Google form that is the presentation survey. If you could please leave Cameron some feedback, good, bad, or indifferent. I'm sure he would love to hear it. I will leave that open for about 24 hours. And then, Cameron, once that has closed, I will get you a summary of all the results.
Sounds like a plan. Oh, I was trying to make a joke here. When you send the feedback, make sure you include the what, when, and why. Because context, right?
Definitely.
Yeah.
Okay, before we go, Sam has asked me if I could plug some upcoming events that he's working on, and I said that I'd be happy to. On September 21st, there will be a .NET study group that he is leading. And then on October 27th, the next meeting of the Cleveland C# VB.NET user group will be holding their meeting, featuring Jeff Fritz from Microsoft talking about .NET 7. So some things you might consider attending. And I will make sure to drop links in an email after this meeting. Okay, well, if there's nothing else, I think we can go ahead and call it a night. Thank you very much, everybody, for attending, and have a great rest of your evening.
Thanks, everybody. Until next time.
Thank you.
Yep, thank you.